Afternoon, everyone. Thanks for being here. So I'm going to run through a series of slides here, trying to make it somewhat interactive. We'll start with an introduction in a minute, and then just look at a definition of what the cloud is, some of the challenges and trends, the flexibility and scalability, and how to support resources deployed into the cloud, and how quickly those resources can be brought online, and close it up with some of the cooler features of the Azure set, including big data and Internet of Things. In fact, some of you in the room are already here engaged with Catapult for some of those exciting new developments in the Azure space. We'll get to that later. I'm Mick Monk, as Michael introduced. I was born and raised in Manchester, UK, and pretty much travelled and worked all over the place. The last 20 years, I've been involved in some pretty high-profile global technology and migration projects right across Europe. Pretty much worked in, I guess, every major European city. Also Moscow, Dubai, New York, and now here down in Texas. I've been a Texan since 2014. I moved here from Paris. Not that one. That one. And yeah, I'm happy to be a part of the Catapult family for the last 6 months, hopefully a lot longer. So a review of the concepts and the trends. What is the cloud? When we talk about the cloud, really, it's generally referring to taking applications away from the desktop and away from on-premise infrastructure, if you like, and hosting them online, primarily with a view to reducing costs associated with the hardware and software and licensing, electricity, real estate, maintenance, all of those things. And what really enables Azure to be able to provide successfully to businesses, public sector, private sector, large and small, is the scale of the infrastructure, which is distributed across 22 regions, currently right across the world. You can see in the US, there's currently 3 regions on the East Coast, 3 in the central region, and 2 out west. And you'll notice 2 of those currently have got the label of US Gov. The US government cloud is specifically aimed at the US government, federal agencies, and state and local government. Some of you are familiar with that. And some of the things that set that apart from the Azure Consumer Cloud are the broad range of certifications that have to be, that have been gained by Microsoft and enable state and local government agencies to be able to move their workloads into the cloud, knowing that they've gone through this rigorous process of obtaining these certifications. Some of the big ones there: CGIS for criminal justice, the health insurance portability stuff, defense, and FedRAMP. I'm not personally familiar with what all of those mean, but maybe you are more than me. But the government cloud physical data centers are physically and logically isolated from the consumer cloud. The 2 in the States at the moment are 500 miles apart in Iowa and Virginia, so you've got really true geographic redundancy there. And pretty much everything that's available in the consumer cloud will, at some point in the near future, Microsoft promises, will be available in the Gov Cloud too. And the Azure Cloud really makes up part of the Cloud for Government solution alongside Azure Office 365 and Microsoft Dynamics. The picture here is basically just showing an overview of the physical space in which Azure Data Center might live, greenfield site. You can see these containers up on the right, which basically contain racks and servers, storage, networking components, all of which are isolated. They got their own cooling facilities inside. And if you think you got it rough working in a cube, imagine how these guys feel on the bottom right there, having to go to work in there every day. So the cloud computing models, we're talking about moving things away from local data center to where everything from the storage, networking, compute, the management of the operating system, everything was having to be managed by internal staff, the costs associated with that, complexities of deploying all of that. And then we move into the cloud space where you've got three sort of components, if you like, of how resources can be deployed into the cloud. First one here is infrastructure as a service. What does that mean? Basically, the physical components of compute, networking, and storage, they're all managed by the vendor, so you don't need to worry about that. You don't have to worry about plugging a computer in, connecting it to the physical network, or the disk subsystem that it needs to run upon. All of that's done by Microsoft. And what you do get to control are all of these features in green. So from the virtual machine upwards, what that means is you can choose to deploy a virtual machine in Azure. You can pick how many virtual CPUs it has, how much memory it has, how much storage you want to have associated with it, and then what operating system you want to deploy upon it. Windows, Server, Linux, fully supported by Microsoft now too. And you get to manage what you install on that server just as you would as if it was running in your own data center. So you have pretty much complete control over the virtual machine and the virtual server itself. Next up is a platform as a service offering, which I guess the best way to describe this would be, imagine your application is packaged and it's contained to where it doesn't care what it's running on, right? You can have it running on infrastructure that's out on the West Coast, but you could also move it to infrastructure that's out on the East Coast. It doesn't really care about the underlying infrastructure. It's just happy, It's packaged up in a box. And a good example of that could be Azure SQL. Instead of you needing to install SQL as a product on top of a virtual machine, Microsoft now offer that as a sort of packaged application. A few clicks of the button and you've got SQL deployed. You don't even need to worry about which version of Windows it's running on. And again, all of the, from the operating system, the virtual machine itself, and the physical components, they're all taken care of by Microsoft. Don't need to worry about it. Excuse me. And then finally, software as a service. Again, great if you don't want to be bothered with managing the application itself. With software as a service, you're really only concerned with the data that you're putting into the service and the access, right? Who can log into that service and who can see the data that's in there. And a good example of that would be Office 365, Salesforce, those kinds of things. Everything else is managed by the vendor, and they just provide an SLA, and you consume the actual application that you're paying for. Talk about how Microsoft are able to provide an SLA on resources that you purchase in the cloud. This is a pretty high level, but the way that the infrastructure is deployed is into what's called fault domains and update domains. And if you imagine each of the three columns there as being similar to racks of physical infrastructure that you would deploy in a legacy data center. So each of those racks would have physical servers, physical storage, physical network switches at the top of the rack, and you might deploy virtual machines to those physical resources within that stack. It's a similar concept here, but the way that you get high availability in Azure would be to make use of what Microsoft call availability sets. What availability set gives you is it spreads out the resources over both fault domains and update domains. So if you have an availability set, it automatically distributes the resources across those fault domains and those update domains. And what a fault domain gives you is basically resiliency to anything that might happen physically, unplanned events, such as a loss of power to the rack, might be network switch goes down in that particular rack. If that happens, you lose fault domain A. Well, you've still got, if you deployed 6 nodes into your availability set, you've still got 4 of them running in fault domain B and C. You might lose another rack, it's unlikely, but if you do, you've still got 2 remaining in fault domain C. And this is just in one region. It's not really, you can go further than this and have a secondary region, if you like, also running this service. The update domain, that's for planned events, and that might be when Microsoft need to perform some patching to the virtual machine that your VM's running on, physical machine your VM's running on, and sometimes that VM might need to have a reboot. Well, Microsoft promised that they will only ever update one update domain at one time, and you can see those update domains spread out across the fault domains there. So if you look at update domain A, for example, that's in fault domain A and C. What they're saying is that updates to the first machine in the first column and the first machine in the third column may well be done at the same time. And if those machines have a reboot and they don't come back up, you still don't have to worry about it, because you got 4 machines spread out across 2 other update domains, B and C. And that's how they basically guarantee the SLA. What you want to make sure is that you don't deploy any single instances into an availability set, because you're not really getting the benefits of the SLA then. Here we've got an overview of pretty much a logical split of what's deployed into Azure and how. And if you start at the bottom, this is a physical layer, if you like, of the data center, the compute, storage, network, physical components, and obviously that's required for the infrastructure services above, upon which runs on that physical hardware. And the Azure services are split into basically compute, storage, and networking. The compute being virtual machines. Pretty much everyone's familiar with what they are. Containers, which would be platform as a service applications, bundled into a container. The storage, where Microsoft offer a number of storage features, if you like, blob storage being the primary one for large files. Premium storage is a more recent offering, which is SSD storage for high performance. And then the networking components, which are the virtual network. That's probably the first thing you actually start to deploy into your Azure subscription before you can start deploying any resources into that. DNS services, load balancing, traffic manager if you want to do geographic distribution of your services, and things like express route and VPN gateway, which we'll talk about in a little bit. Above that, there's the platform services, and this is basically the end user product offerings, everything from web apps, logic apps, big data, HD Insight, Azure SQL database, SQL data warehousing, and on the left-hand side, the security and management logical bit, which really is similar to identity and access management that you're used to on-premise. Predominantly, that's Active Directory based, and indeed, Active Directory forms the basis of identity and access management in Azure as well. Again, we'll talk about that a little bit more coming up, how you can extend your Active Directory on-premise into Azure. Some pretty neat stuff you can do with that. On the right-hand side, the hybrid operations. These are services which allow you to, monitor between, manage resources between on-premise infrastructure and resources that you've deployed into the cloud. So, you've got a hybrid mix of some services running in Azure, some that are still on-premise. Some features that could make use of the hybrid operations would be backup. You could start, using Azure Backup to back up your on-premise data to Azure Backup, which is hosted by Microsoft. So you've got an off-site data backup repository, which beats the good old tape, storing tape on site and having it shipped to a second site. And operational insights, you can have a look at how well your resources are operating on-premise compared to those that are operating in the cloud. And Store Simple, that's another cool one. You can have a virtual appliance running on-premise where you have tiered storage, which basically will start to offload storage from expensive storage systems that you might have on-premise. Let's say you've got data that hasn't been looked at for more than 30 days. You don't need to be storing that on premium SSD storage on-premise, right? You can just have that Store Simple device will automatically offload that, ship it off up to Azure and store it on cheaper storage, and basically freeing up some of that more expensive high performance storage that you've got on-premise for other purposes. So what's one of the primary success criteria for moving to the cloud? Planning, really, that's a big one. The cloud is a highly connected, off-site, co-located data center that you share with other people, but it offers a set of highly optimized virtual services, at reasonable to low cost compared to managing your own infrastructure. But it's really crucial that you do a full assessment of what you have on premise and whether it's suitable to start moving those to the cloud. You need to really figure out what services you've got on premise and whether there's an easy route to moving them to the cloud, and whether you can move them to platform as a service, whether they need to run on a virtual machine in Azure, if you can move it to a software as a service offering. For example, you might be looking to move Exchange 2010 away from your global data centers and move to Office 365, and that would be a direct mapping to software as a service offered by Microsoft. Catapult has a cloud readiness model here. Starting at the bottom, there's 6 levels, 7 even, of readiness. Starting at the bottom, and these are, really, you step through this and gives you some insight as to where you might be now and where you want to get to. If you're at level A, this is really the educational bit, learning all about what the cloud can offer you, what it can do for you. B would be a proof of concept, to have someone come in and take a look at what you've got on premise, do a proof of concept with maybe one service, moving it off premise and putting it into the cloud, or having it run in parallel in Azure while it's still in production in the cloud. Doing some costing analysis, whether it's good return on your investment, and then how you'd actually move it up there. What processes, what resources do you need to facilitate that migration plan? And once it's up there, how do you govern the operation of that resource? You're moving it, after all, from infrastructure that you're used to managing. It might be, under change control procedures, things like that. How do you adopt those procedures into a cloud model? Readiness level F, well, you're running your operation in the cloud. You need to keep a close eye on making sure that it's meeting performance SLAs. You've got resiliency, as you would expect. And then finally, when everything's running up there, you start to focus on optimizing how it's running, maybe distributing it further to more regions across the US, or even further afield to Europe or Asia. And then implementing automation techniques to where you can really leverage some of the features of the cloud to automate business processes and make your IT operations even smoother. Again, Catapult came up with this cloud computing maturity model, and basically six steps there. Level 1, there's none. You have no real approach at the moment. You're not even considering the cloud. Level 2, it's you've got a cloud subscription established, but your developers have just been messing around in there for a few weeks, and no one's really taking it seriously. Level 3 is more of an opportunistic approach. Management might have decided on, hey, we've heard about the cloud, what can we do with it, and start playing around and seeing if we can get some value out of it. And level 4, a systematic approach. So, that might have been reviewed by management, your operations teams, and resources. You're starting to deploy resources up there, and seeing what resources can be moved more and more. And level 5, you've got the managed level, where you can really start to measure measure and govern what's up in the cloud, whether it's suiting your organisation. And then, similar to the previous slide, where you start to optimise your resources based on the metrics that you're gathering from performance and proactive monitoring of the resources up there. This graph basically maps to each of those levels. As your timeline goes on and your maturity increases, there's a direct mapping to the consumption of cloud resources. So what are we seeing in the industry currently? Well, a lot of people are saying they'd like to do more, but with less, right? Less resources, less expenditure, and this leads to an evolution of a hybrid cloud model, which Microsoft fully support, and it gives you a method of really simplifying your operations and making the move to the cloud a little more streamlined. You can take your time with it. You can have resources running sort of in both places. A good example of this would be extending Active Directory to the cloud. It's where you can start deploying your domain controllers off-premise, extending your on-premise data center and Active Directory services up to Azure. With a modern data center, you've got flexibility of service delivery, of course, so where it's easier to deploy these things. You don't have to go through necessarily a long provisioning process, speaking to the accounting department, putting it out to tender. All of a sudden a few clicks and you can start deploying things faster than ever. You've got more economic control over the resources that you deploy. You can tag the resources that you build in Azure to make sure that you've got some insight as to who's using what. If the accounts team maybe need to have auto-scaled server at month end to run some payroll processing, you can tag that resource to say, well, how much was actually consumed for those 3 days at the month end, and then accounting has a chargeback model they can build themselves for, right? Excuse me. And historically, and maybe even currently, the train of thought was, you need to justify moving resources to the cloud. And going forward, I think, even if not now, certainly in the next 5 years, the justification will be more along the lines of, why should I keep this on premise? Why shouldn't it go to the cloud? And I think more and more, companies and organizations are going to start thinking along that route, because just how easy it is and how much cost savings there are associated with it. But it has to make sense. It doesn't make sense to move things if security compliance doesn't meet with your organization. What's maybe stringent control to where the data that we're talking about has to stay in your on-premise data center. Okay, you can keep the data there. Perhaps you can move the application up to the cloud and have it talk back to that data. So even in those situations, there's still room to make use of some of the cloud resources, even in the tightest of constraints like that. Velocity, we spoke about. IT must be able to deliver quicker than ever. DevOps teams need to be able to develop applications and put them to market faster than ever. Those guys don't want to be waiting 6 weeks to have a virtual machine provisioned because they go through weeks of change approval internally. They can have their own Azure subscription and basically have their own sandpit and deploy that whatever they developed into production within a matter of minutes or days if they want to. What else? Analytics, the power of big data and business intelligence. This just wasn't possible without the power of the cloud, unless you have heaps of money and tons of compute and storage resources to play with. And there's been some huge improvements in this space, and certainly in the last 3 to 6 months, and it's getting better by the week. So I'll talk about flexibility and scalability. How do you connect your on-premise to Azure? There's the hybrid cloud model, which we spoke about a little bit already, and this is all about connecting your on-premise to Azure and how you go about that. You need to make sure it's secure. There's a number of ways you can connect to Azure. The most basic and relatively unsecure is just using the internet. In addition to that, we've got site-to-site VPN, there's point-to-site VPN, and also ExpressRoute. But one of the first things you do is create a virtual network up in Azure, and this is basically your own private secure network dedicated to you within Azure. And that can be an address range in either 10.0 space, 172 or 192 space, as long as that IP range doesn't overlap with anything you've got on premise. There's no danger of running out of IP addresses up there. And you can look at this environment in Azure as basically your own virtual data center. You're sharing the physical infrastructure, of course, with whoever else, but you've got your own sort of space carved out, fully secure. The methods of connecting point to site, well, that's similar to what some of you might be used to already, using a VPN client on your laptop. So where you would just connect up to Azure. That's basically, point to site your machine to the data center. For small to medium businesses and enterprise, very often they deploy site-to-site VPN, and that will basically connect using your existing VPN gateway on premise with a secure, still over the network, but it's a secure tunnel to your Azure virtual network. Obviously, you've still got some speed constraints there, but it is a secure tunnel. You're not just going over the public network. And then if you really want speed and higher resilience, Microsoft offer what's called ExpressRoute. And that's really a dedicated pipe between your data center and Azure. Speeds up to 10 gig. It gets expensive at that point, of course, but if you want mission critical workloads and you need that, resiliency for disaster recovery, high availability, then ExpressRoute is the way to go. One of the first things and the cool things, in fact, that Catapult offers is called the Azure Foundation Framework. And this is basically extending your Active Directory into Azure. And how do you do that? So you build your virtual network, you get your network connectivity set up, site-to-site VPN or ExpressRoute, and then you start deploying domain controllers into this virtual network. Once you've done that, and you've got those domain controllers, communicating back to your on-premise network, initially they'll use DNS on your on-premise location. And once you've got that, once they can talk to DNS, you can promote them as domain controllers into your existing Active Directory. Once you can do that, it's a case of setting up a new AD site in your Active Directory, and all of a sudden you have a new branch office up in the cloud. So you've got an extra AD site, domain controllers which are giving you more availability, and let's say you have an application deployed into the cloud which has a public-facing endpoint. So you're looking at this application over the internet, but it requires you to log in using Windows authentication or single sign-on. Well, what it can do now, the application can just simply reference one of the domain controllers that you've deployed into your virtual network. It doesn't have to traverse the virtual network back to your on-premise just to talk to a Windows domain controller. That authentication method happens just in the cloud. So you're kind of relieving your on-premise DCs of that additional load. So pretty cool stuff. This is not a very pretty slide, but it's just to give you an insight as to the virtual network you would see in your Azure portal. On the right-hand side, these are your subnets. So once you establish your virtual network, you're free to carve that up into whatever subnets you like. And the recommendation really is to, basically carve up subnets depending on the roles in question. So if you want to have SQL deployed, build a new subnet for that. Active Directory domain controllers, build a separate subnet for that. Internet-facing IIS servers, for example, build a separate subnet for that. And why would you do that? Because in Azure you have what's called network security groups, and these are basically similar to legacy firewall rules, right? To where you can build a network security group, you can assign that network security group to your subnet, and you can say, okay, this network security group has rules in place to where I only want the IIS servers to be able to communicate to the SQL servers, and they can only communicate on port 1433, for example. And that means you're locking down your SQL servers in that subnet to where even your internet-facing application server and the end user, there is no direct route to your SQL server. Right? It always has to go through your subnet, which is where the IIS server is, and there's no security risk of anybody, getting direct access to your SQL database. So that's just, one of the best practices of how to deploy resources into your new Azure environment. So what are some of the success stories? Client data center perhaps needs to have extensive hardware refresh done. Cost associated with that can be pretty astronomical, even cost prohibitive. But your business users still want to have full access to the data, so what can you do? Well, you can look at moving several of the main applications into Azure. Have a SQL always-on solution, which basically replicates data back to your on-premise SQL. So you're still retaining that data on-premise, but you've got, secondary copies of it spread out across different Azure regions. You're deploying that SQL Server solution much cheaper than you would be able to if you were having to, buy your own servers for it, install SQL, manage all that replication of the database, and so on and so forth. Another one might be, investing in new servers and storage for a new line of business product to be deployed outside of your current region. Let's say you've got an operation in the US, you don't have any data center or anywhere to put new hardware in Europe, and the cost of doing that in a co-location facility, it's pretty high, right? You've got to think about network components, how you're going to link the two data centers. Perhaps $250,000 of investment. Easier solution, you can just deploy into the European Azure data center and connect that back to your US location with a significant cost reduction. 48,000. I'm not quite sure how accurate these figures are, but yeah, fairly significant whichever way you cut it. Yeah, another one. This is quite cool. You know, you want to put some resource, or you have users that want to access an application that you've deployed into your data center in the US, but performance is poor, right? They're trying to get to it from Spain or Germany, and they're coming over the internet. You know, the physics of the latency of the network come into play. They might not get a good user experience, so what can you do? You can have them connect via express route to an Azure data center or region that's closest to them. So they might route into European 2 data center of Microsoft, and then traverse the Microsoft backbone to get back to your US resource. And then you're only paying for that connectivity of the express route from where your customer's located up to the European data center, and the rest of that traffic is traversing the Microsoft network in the background. Velocity of speed to deployment of applications. We spoke about this a little bit. DevOps is not really my area, but this walks you through the sort of life cycle of what's required there. The developers, you know, they have a core repository of their coding. They want to build quickly, test and deploy quickly, and with logic apps and web apps available in Azure, they're able to do this at lightning speed. They can throw it up there, monitor it for a few days, make their improvements, and pretty much have it deployed into production quicker than ever. You know, something that normally might take 3 or 4 weeks to bring a developer in, onboard him or her. What do they need to do? Get them accustomed to your environment, how that's all set up. You can, get a guy, say we want to deploy this into Azure, and have that set up in, days rather than weeks. Similar one, SharePoint. That's a beast of a solution to deploy. You've got pretty sophisticated infrastructure requirements and knowledge required to get that up and running. Again, might take 4 to 6 weeks to get that set up. You need specialist deployment teams, SharePoint teams, DBA teams, and if you go down the route of SharePoint Online or using components of Azure, again, click, 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 you can have that deployed in days rather than weeks. Moving on to big data and Internet of Things. Some of you guys in the room are already here. I spoke about it earlier for the data analytics program that we're doing a proof of concept of in conjunction with you at the moment. What's big data? Categorized really by the 3 V's: data velocity, data volume, and data variety. All of those things are expanding on an ever-increasing rate. I mean, the sheer volume of data that's generated, just on social media, let alone in the healthcare industry, manufacturing industry, you name it. Data is growing, some would say, out of control, and what do you do with it all? You can't just keep buying disks and backing it up on premise. You need to have some kind of solution going forward, how to not just store it, but how to harness it as well. Internet of Things, current buzzword, what is it? Well, you've got all kinds of things, things that are having sensors built into them. It could be refrigerators, cars, watches, medical devices. All of those things listed up there. Security cameras, ovens, televisions, they all need to start talking back to something, right? How do you connect them? What do they connect to? And what's the use of them connecting to anything? What are they going to actually give you? What's that data giving you? These are all sort of modern take on technology as we know it, and pretty cool stuff. But why is it happening? Well, because now it's it's actually cheap enough. Never been cheaper than harnessing this new technology. And again, the power to be able to store all this data is at your fingertips now, like never before. It's cheap. You only pay for what you use, so you don't need to invest in premium storage that you might not use for 3 more years, but you need to buy it because, I don't know, CapEx says, well, you won't have any money next year, so buy it now. You go to an OpEx model and you basically lease storage and pay for it as you need it. And there's a whole integrated suite of products in Azure to address some of the challenges with big data and Internet of Things. None of it's particularly straightforward, but it is getting easier of how these products can be deployed and how you can make use of them. But these columns are basically logical sort of logical components of where they all fit. So on the left you've got the devices. We talked about cars, handheld devices, laptops, computers, cameras. You've got the connectivity, what's required. You've got event hubs, which is an offering in the Azure space, service bus, external data sources. These are all methods in which you can connect these devices up to the storage tiers in Azure. That might be a SQL database, just simple file store, table store. And once you've got it into your storage in any of those formats, you can then start performing analytics on it. With any of these features available in Azure, HT Insight, that's really powerful number crunching capabilities where you can have, spin up mass scale compute processing for a few days and really do some powerful number crunching. Stream analytics, machine learning, really cool one, right? You can start looking at trends, what's happening in that data. I mean, you've got all this unstructured data. Nobody knows really what's contained within that data. Where machine learning can really start to look into it and try and develop trends, who's saying what in that data, and then what does that data map to, and then the presentation and action upon that data. It's all well and good having this information, but how are you going to present it? And there's a variety of ways, Power BI being a big one from Microsoft. This gives you basically dashboard views and really awesome graphical interface to all of that data that's sitting in your storage tier and the analytics in real time. Again, some of you guys are here to see that in the business analytics project. You can present that to mobile devices, big projections like this and so on. So again, we talk about some of the success stories where that stream analytics might come in. You got a global manufacturer, they want to identify risks to their supply chain. They might have a hyperscale collection of data from all the manufacturing plants scattered all over the world. Each one might make certain components for their product, and they want to make sure that their overall product isn't impacted by the manufacturing of one of those components. So they want to be able to identify any threats and trends of the particular supplier. One of the suppliers of a critical component has a fire. You've got a guy all of a sudden, running for his life out of the factory, but he finds time to throw a Twitter feed up there saying, factory's on fire. You get wind of that, and within minutes you're able to say, okay, hey, we need to find an alternative supplier. They're gone, and you're able to react pretty quickly and hopefully without any major impact to your supply chain before your competitors step in and take over. And that's just something that you might not have been able to do in real time before. So these are just some of the figures talking about the opportunities of Internet of Things. Again, These figures come from IDC. You can see between 2014 and 2018 some of those predicted growth figures, pretty astounding right across the board. Government rising by 200 billion, utility sector, transport, healthcare, retail, manufacturing and banking. So, you know, pretty much room for every line of business, not least medical. You know, some of these new sensors that are being manufactured, wearable sensors, right, for medical purposes. It's getting to the stage where you might go home with a sensor that means you don't have to go and report to your primary care physician every day. It's sending data back on particular aspects of your health, and an alert will be generated to your doctor if, you know, something goes crazy. He'll call you, you don't need to call him. And you know, this is all technology that's evolving rapidly, and it's getting more sophisticated by the day. Again, business need. Medical device company might want to collect all that biometric data, perhaps record, you know, seizure patterns, be able to alert caregivers, send paramedics over, and you know, assuming that you don't need a paramedic, well, at least you've got all this data which they can do analytics over the course of days, weeks, months, and you know, give you some valuable insight into, you know, the health of what the device is reporting on. But you know, there's some challenges there. These devices, they collect a vast amount of data. One of those devices might collect up to 31 billion data points per year and per device. So again, you need to have a phased approach. It requires mass storage to harness all that data. You need the processing power to do something with the data, and then the ability to analyze the data once you've harnessed it. So wrap it up. Cloud computing, what's it do? It gives us the power to do things we've never been able to do before. You've got ease of scale, reduction of costs, and simplification of the management of your resources. And you know, I like to think of it as having gone full circle. My dad used to work in computers and back in the 70s on mainframes, and talk about, you know, one day, you know, everyone would have a PC at home, and you know, we've gone from the mainframes to the birth of the client-server technology, and now, you know, we're sort of back to that centralized mass processing ability, you know, where, you know, cloud computing is, you know, the power of the mainframe again. And I guess the big difference is, you know, the power of your iPhone far succeeds, you know, the power of what was in your PC in 1995. And that's it. I'm done. More power to the people. If anyone's got any questions?
Could you speak to a term heard before, private cloud infrastructure? What's the state of it in the industry? What are the big picture, what are business needs? And then maybe drilling down a little bit, whether it's SCCM or whatever tools or vendors are companies still using it? How effective is it?
Yeah, absolutely. I mean, the SCCM, I mean, you still need monitoring whether you've got, you know, private data center or public. You've got OMS, which, you know, gives that hybrid monitoring capabilities, ties in with SCCM. So I don't think SCCM is going to go away anytime soon. You know, there's probably going to be more of a requirement to keep an eye on what's going on, right? You're not in control of where your services are running quite as much as you were before, especially if you start adopting platform as a service. So I don't think anyone's going to be throwing away their SCCM environments anytime soon, which, you know, great product, and I think it's here to stay for a while. Microsoft will certainly plan on building upon that, I think. Yeah, the private cloud, I think there's going to be more of a shift away from private cloud models into public cloud, just because of, you know, the investment into the public cloud offering It's probably going to get more and more, you know, as the years go by. I think, you know, the big players are going to have more money to throw into their public offerings rather than some of the co-located facilities. You know, you already see people like Rackspace, you know, scaling things down a bit, going back to what they know best, and you know, Amazon, Microsoft playing catch up a little bit to Amazon, but they've always been good at playing catch up. So I think there's going to be more and more people focusing on a definite shift to the public cloud. Yeah.
Mick, I know you had a slide in there around continuous delivery and the ability of the cloud to. I know that's not your core skill set, but there's some new technology coming out there that's pretty exciting. Anything?
Yeah, it's not really my area of focus. You have to get Alonso to talk about that. But yeah, I mean, continuous development, automation of application deployment, and you know,
as well as the ability to spin up large test environments and take them down very quickly after you've used them. So
Yep.
Performance testing becomes a lot more
absolutely
achievable.
And logic apps, you know, things like that, offerings which you know, you can automate business processes by the triggering of an event. You know, within one application, it might start having a domino effect and start spinning up other resources in Azure as the application dictates. So, without the need for human intervention. I guess a good example of automation is Catapult's launch feature, right, where you can launch is basically automated provisioning of user accounts. People join the company, you know, HR might log them in the system, and then you've got a series of events that provision their account, order them a laptop, you know, all that good stuff, and no human intervention anymore. So significant savings in resources there.